I'm JC, and my partner for this project was Heather. In this project, we recreated the risky business scene to gather data for the Greek letter mu. Mu is the coefficient of sliding friction. This was another way for us to calculate forces. We did 5 trials of sliding to find our acceleration. Meters was our measurement for distance, and seconds was our measurement for time. We plugged each trial individually into the equation x equals 1/2 at squared. Distance was x and seconds was t. After that, we took all of the accelerations we got and averaged them. Our average acceleration came out to be 8.94 meters per second. Newton's second law was where we would plug all of our data so far into so we could later create a free body diagram. The equation is acceleration equals net force over mass. Net force stands for the unbalanced forces. To find mass, we converted pounds into kilograms, so 88 pounds was equal to 39.9161 kilograms. We took the same acceleration from the last picture and rewrote the equation to find net force. Net force equals mass times acceleration. Here is where I'll explain why our net force came out to be negative. I started the free body diagram with a dot representing the object in motion. I drew the arrows according to the directions of the forces. I found force of gravity and normal force to equal 399.161 newtons with the equation force of gravity equaling mass times gravity. Gravity is usually equal to 9.8, but in this case we were able to round to 10. Then I added my net force to the diagram at force of friction. It is negative because I was slowing or accelerating in the left direction. Finally, we are able to use all of that data to find mu. Notice that in the equation, my force of friction is negative, but that does not affect mu because mu is absolute value. You end with just a number because mu does not have a unit. The equation will be mu is equal to force of friction over normal force. So it was negative 356.85 over 399.161, and the answer came out to be 8.9.